Genau, wir haben Emily Jiang als Keynote-Sprecherin hier. Is it okay if I continue first in German? Okay, perfekt. Von IBM. Emily ist Cloud Native Architect bei IBM und macht heute sowohl für die JakartaOne als auch für die Cloud Land die Keynote. Und ich freue mich, dass sie heute zu uns gekommen ist. Und ja, it's your stage. Thank you.
Thank you. Thanks for coming. Yeah, great to be here. And hello, everybody. Hello to everybody in this room at Cloudland, and my greetings to the people who joined remotely. So in this session, we will just look at the microservices. Actually, the microservices has been around for some years, right? So it's in this session, I want to look at the history of microservice and also the facts and the myths about microservice and things that you should know about microservice. And then we'll look at is microservice is going to be obsolete again. This is a technology like repeat itself again and again, right? So let's first rewind back to back to the older days, and let's see what generated microservices. So it's back in the 1997, IBM released the EJB. Who knows EJB? Yeah, that's great. So it's I remember that when I joined IBM, I had to go on a course to learn about EJB. So you have to use IDE to generate stubs, be able to do the remote, the service calls. And it's very complicated. And the other thing is only the technology for Java. Actually, we want to do this remote call between the services in the different languages. So with that, it came SOA. So service-oriented architect. So the basic concept of SOA is about language agnostic. So services can be written in any kind of languages and etc. So this is very popular in 2000. And then also the SOA came with the enterprise integration bus. So basically the idea is you send the messages between the services. And for these communications, it uses a protocol, SOAP, Simple Object Access Protocol. And for SOAP, actually, the original design is simple. However, it's not simple. And everything needs to wrap it up in XML. Because I started working on these services in 2006. At that time, SOAP was still quite popular. And with this, all the web services kind of standard was created, like WS addressing, WS policy. Anybody know WS web services standard? Okay, a few. Actually, I kind of fortunately or unfortunately have worked on the WS addressing and WS policy and dealing with the XML all the time. And you have this WSDO to Java, all kind of different tooling. It's really complicated. And then it's in the 2008, that kind of period of time. And people think, oh, okay, this is too complicated. We need something simpler. So that came with REST. So representational, like a state transfer. So basically, with REST, basically you have the get, put, and post, and delete. So this operation, all the APIs, you can either be one of these operations. So this is REST. REST actually staked. It's become popular and popular. So and then service will be able to use REST to communicate with each other. And then once it's stable, and we need a name for these services. So in 2011 or 2012, is the microservices that came out. So basically, it's okay. This is just services. They communicate and sometimes via originally via this REST. So we call it microservices. And because of the microservice name was created, and then we need a new name for the traditional application. And then we give it a kind of a name, let's call it a monolith. Right? Like, what is a monolith? Okay, the big blob. And then it's kind of, and then, it's kind of this, we always like the new things. And then we just say, oh, okay, all the things is bad. And is monolith bad? Is it old-fashioned? It is evil? Like people in the past, oh, it's evil. Monolith is evil. You need to go to microservices. So let's look at what is microservice first. And then we can go back to think whether monolith is evil or not. So it's according to the microservice.io. So microservice need to be maintainable and testable. And the very, very important thing about microservice is need to be independent. So as you can see here, like on the top, so basically each microservice has a clear identity, right? It should be able to be released, independently. Shouldn't need to negotiate with others. And it should be owned by the single team, like a small team. If it's one team, you own like hundreds of microservices, you did it wrong. You haven't done the right architecture. We have done microservices for a decade. So there's kind of some myths about microservice. And then often people ask me, I don't know, maybe you also got this questions, how small should I do microservice? Is it 10K big enough? Is that like one class? Is two classes too big? Is that just one class? So this is all wrong questions. If you got this question, that means that person haven't understand microservice correctly. The other thing is people are saying, oh, okay, are you doing microservice? No, my company is really old-fashioned. We are still on monoliths. We need the time and resources and budget to move to monoliths. Actually, microservice is not a destiny. And sometimes maybe your company is suitable to do monoliths. It's before you rush to microservices, find out what's your problem. If you do not have a problem, do not create a problem. Actually, in preparing for this presentation, I did a survey. I asked, do you think a microservice are going to replace monoliths? You can see more than half says no. So you should rest assured, if you're doing monoliths and you do not have any problems, you do not have problems. Don't rush to microservices just for the sake of microservices. So because we can only hold three things, I just mentioned the top three. So third thing is kind of, if you have some organization problem, you said, okay, my team is not performing well. Probably because we are doing monoliths, we should do microservices to increase the performance. Or your application is not running fast. Maybe I should do microservices. You should have to look at the problem. Why is it slow? Is that you are not using the correct runtime, right? If you do not look at the problem and rush to microservices, eventually you will create distributed monoliths. It's even worse. Actually, some companies already kind of provided evidence. And back in the 2020, before the COVID, I went to the QCon London, in London, and then one company is called Segment. They just did a talk about why they moved from monoliths to microservices, and found out actually their team performing badly. They have a performance is kind of deteriorate. So they had to merge the microservices together into monoliths again. And also because I tweet about microservices, so this company is not alone. And also Adam Bain is also suggest something so in a funny way, is merge microservice into monoliths, and then give it a cool name. So it's this means like if you haven't designed microservices correctly, maybe you're better to do monoliths. Maybe if your team efficiency will be increased. So what are the microservice facts? Microservice is about independent deployment, and it's basically if you cannot remember everything I said, remember just one thing: microservice is not about a size; it's about independent deployment. You need CI/CD to enable the independence. So basically, you need continuous integration and continuous deployment. And also it's owned by a small team. If you have a big infrastructure, own many microservices, eventually you all aggregate all these microservices, synchronize microservices, and release at the same time again. You just not doing the correct microservices again. So the other thing is the second thing, microservices doesn't do code sharing. Back in the 2019, so I was at the Berlin We Are Developer Conference, and actually I have a lot audience in the room. And then is one person saying, actually, how can you enable code sharing? So I need to do a shader library, and I said, in microservices, you don't do code sharing. If you have to do a lot of code sharing, so that means you haven't designed it correctly. The other thing is no database sharing. Every microservices, you should have an independent database. It have everything, so it's basically it has its own identity. The third thing, microservices. This is at the beginning of microservices, and I think back in the 2015 at that time, and people talking, oh, Java is dead because we have these new microservices. You need a new technology, new programming language to go with it. And then people say, oh, you need to use Go, or you create a new language to do it. Actually, microservices can be written in Java. Java actually have a great ecosystem. I will demonstrate to you later. And to enable to do really, really good microservices development. And also, you could choose Go or Python to go with it. Okay, by now you kind of roughly understand the microservices. What kind of things you should know if you do microservices? Is microservice the default answer for your problems? When you have a problem, you say, oh, okay, yeah, I have a problem with my monolith. Somehow the monitoring is not doing well. I can't figure out what's wrong if something is wrong. Probably I should go with microservices. You have to ask why you haven't got monitoring. If you directly go with microservices without adding any metrics and etc., you still run into the same problem. So you need to find out what's the problem first. So don't rush to microservice just because you think microservice is going to fix everything. No. The second thing, microservice needs a really good design. A microservice is not simple. You need to think clearly about it. You need to learn about domain-driven design. So basically, you need to structure your application in a nice domain-driven this kind of architecture. And then, if you want to do the asynchronous communication, you also need to learn about event-driven architecture. Please do not do resume-driven development. And I know we are developers, right? And we like cool technologies. We say, oh, this is kind of some other technology. That's a new technology. We got to use it, and let's use that. And this is you can learn in your spare time, but do not put into just use the personal goal and driven the microservice design. And when you do the microservices, obviously, you will have a few microservices, and then they will deploy it to the cloud. So day two operation is very, very important. You need to have the right metrics, and you need to have the tracing availability, or also you need to be able to communicate with the cloud infrastructure. And also you need to use the standard programming model so that you can communicate these microservices no matter what kind of technology or they use. So it's no matter which runtime it use. The fourth thing is kind of when you do microservices, obviously you need to adopt agile kind of the kind of practice, and also you have to change your team structure, make sure you are doing microservices. Not like you have a humongous team and manage like 10, 20 microservices. And then the fifth thing is if you want refactor, if you really think like because you have a monolith, some part of monolith need to be scaled out or scaled down independently, this is really valid use case for you to like chop your microservice into like chop your monolith into microservices. But you need to be mindful on how to you like split these monoliths into microservices. There's also some patterns like strangler pattern and some other patterns. And also in IBM, actually we use AI to direct it like refactor monoliths to microservices. We have a project called Mono to Macro. So basically, we use AI to monitor like the real business operation and use that data and to figure out the context and etc. And to be able to like recommend what the microservice boundaries are. And because today is the kind of microservice and domain-driven development day, so there's many like talks about microservices and also best practice. So check out. So what is DDD? So what's the domain-driven design? Actually, this I quoted Martin Fowler's definition. So it's about like you understand the business operation, and then you divide the boundary. So each boundary is so that will become like a single microservices. So it's a kind of independent operation. So I briefly also mentioned the EDD. So EDD is a kind of event-driven architecture. When you do the event-driven design, and often you will see Kafka here. So basically, it's the event-driven design is like a microservice do not directly like connect to a HTTP call to others. They communicate via messages. So here it will be message broker, and often it has a database. It needs to persist the messages. So Kafka will fit into here. So it's kind of, you often talk about Kafka, but this is a real architecture about what's event-driven architecture. One thing I want to like emphasize, the world won't be like the only one color. So it's a monolith and microservice will coexist for a long, long time. So you need to be just mindful. So again, monolith is not evil. So it has a reason to exist. What you really need, you do not hang up with the term monolith or microservice. What you really need is a cloud-native application. What is a cloud-native application? So it's a cloud-native application. Obviously, it needs to be native to the cloud. I just talk about the application itself. So this application needs to be RESTful. Basically, it needs to be kind of stateless, and it's like a cat or no pet. So it can be grow or shrink. So it can be duplicated or kind of decreased. The other thing is it needs to be configurable. So So basically, if you want to configure the value of any configure properties, you should not need to redeploy your application. So you should adopt a 12-factor app. So externalize your configuration. The third thing is your application need to be resilient, because once you're running in the cloud, and anything could happen. Like a backend may not be exist. So you need to cope all kind of different faults. The fourth thing, because if you go to the cloud, obviously, and you will run into the situation, or you couldn't remember which app is doing what. So it needs to be discoverable. So it can document itself. The fifth thing is it needs to be secure. If you deploy a lot cloud-native applications, and each of them might have some sensitive information, so you need to secure them. And also, it needs to monitorable and traceable. If something goes wrong, you know which one is wrong, so you can fix them. Finally, it needs to be smart, intelligent. So basically, it's the cloud-native application. Why is it cloud-native? So it be able to communicate with the cloud infrastructure, tell the cloud infrastructure whether this application is ready to receive request or not. Or if it's sick, it says, oh, I'm not going to recover myself. Please restart me. So this is the kind of thing. And then you might think, okay, this cloud-native application is really difficult, right? It's let alone your business logic. I mean, we are paid to create applications with this extra requirements, you have to work extra time. Probably you have to work over the weekend, etc. So it's luckily, we have the cloud-native API standard to help you. So Microprofile and Jakarta EE. So this is all standard. This is all cloud-native standard. When I call it a standard, the proof is you have a lot of runtimes to choose from. It's not only one vendor. For some, we know, our company has been you have companies moved very fast. Sometimes one company being bought by another. And then top organizations, like a director said, okay, we need to use a different runtime. If you use this open standard, that's fine. Yeah, it's if you previously run on Wildfly, now you can run on Liberty, no problem, right? So this is the real beauty of this standard. So today is also JakartaOne Livestream German Day. So it's also we'll talk about a lot later about Jakarta EE 10. So one thing I want to highlight, Jakarta EE 10 has a new profile. It's called core profile. So you use this is a standard from this core profile to create services, to create cloud-native applications. Plus that, you will use the APIs from Microprofile. So Microprofile is the community. So pin all the specifications together, offer you a very, very solid cloud-native application design pattern. So as you can see here, you can use the Jakarta specs to create an application, and you use Microprofile REST client to connect these microservices together using REST. If you say, okay, yeah, I want to do the asynchronous communication, that's fine. You can use reactive messaging. So this is directly you can plug in Kafka. That's fine. We'll do that. And also the config is directly this implement 12-factor app, basically externalize your configuration. And then you use Open API to document it, and you use Microprofile fault tolerant to secure it. You use use this one to make it resilient. You use Microprofile JWT to make it secure it. And also, if you have a frequent query, to run, and you might consider to use microprofile GraphQL. And on the top, this is all about analytics, observability. So you use open tracing to directly connect all the traces back together to form one trace. And also you use microprofile health directly communicate with Kubernetes. And you use metrics directly add any additional application level metrics. And also give you, provide some like JVM metrics as well. And as we know, like open tracing and open sensors merged together and become open telemetry. In microprofile, we are currently working on the microprofile telemetry to just align with the open telemetry. So with this kind of the release, we will just replace the microprofile open tracing. So as you can see, you have a full stack of the cloud native APIs available to you. All you need to do is just use this API and concentrate on your business logic. Your application is very, very small and kind of fast to get started. Obviously, I talked about a lot of cloud native. Obviously, cloud native, the destination is into the cloud. And you need to make sure it can run in the cloud natively. First thing you need to do is containerize this application. Obviously, you either use Podman or Docker. Who uses Docker at the moment? Okay, great. Who uses Podman? Okay. So Docker is still on the rise. However, I think people gradually probably will move to Podman because of the kind of the license and etc. And with one thing I want to say, with the cloud native application, and if you use standard APIs and etc., it can run perfectly in either private cloud or public cloud or hybrid cloud without any single change. So with that, let me do a quick demo to show you what I have been saying. So it's, can you see it's big enough? Yeah, good. So here, actually, I use microprofile starter. So microprofile starter gives you a way to start to create a microprofile like applications. If you use the starter.microprofile.io, or if you use any like IDE, who uses VS Code? Yeah, great. So if you use VS Code, also we have the microprofile extension pack. Basically, allow you to create a microprofile application. And who uses IntelliJ? Okay. Also, we have a plugin for the IntelliJ to directly create this is a microprofile application. So at the moment, I have two applications created. So it's a service A and a service B, right? Service A, like basically simulates like a service A is one microservice, and a service B is another microservice. So service A like invoke a service B. So in service B, it has two API. So one API is the kind of the do something. So it's basically this is really like a simple operation is a get. See, you can see this is RESTful call. So this is get, and then it's a path. We use JAX-RS, Jakarta RESTful Web Services. And then you can see here, I deliberately put in some sleep and through some exceptions to demonstrate sometimes it's not stable. And this is one like operation. The other operation is kind of this operation is secured. So this is the endpoint is a get operation. However, I use the Jakarta security. So basically, I only allow rows belong to protected invoke this like a backend. So it's now if you now if like in the service A, how could I be able to make a service A invoke a service B? So it's in service A, so for invoke the service B like endpoint, so basically I use microprofile REST client. So I create an API. I created an API for microservice B, cloud native application B. So this is an API. Do something is a get operation and is a path. And then like I annotated with register REST client. So this is a direct from microprofile APIs. And then in my like JAX resources, I can directly inject this service. So basically I do add inject REST client and inject this service. After the inject this service, I can directly call this service. I can do a service to do something. And you might confused. Like now is service B is up running, like in the one port, and service A is here. How does the service A know where service B is? So we use a microprofile config. So microprofile config so directly like provides a microprofile.config properties file. So basically, you can specify any properties from here, and it's the property will make it available to the application. So you can do the like a fully qualified class name for the service, basically com.example scene4g.client.service /mprest/URL. So I put the service B's backend there. So you know it's like a service node, a node where service B is. So in this way, as you can see, I started the service A already. It's on the 9080. So this is running on Open Liberty. Running here is a let me go in here. Here's a 9080. So this is endpoint directly call into service B. So here, like let's try it out. Here I said, hello cloud native cloud dev 2022 service B count. Let me like go to service B. So I started Liberty in the dev mode, so which means it's, if I change something, it will automatically figure out I have some change, and it will reload everything. So I will say hello again. So before the service B count. So if I directly call it again, so you can see straight away, like in a flash millisecond, you can see it restarted itself and reloaded itself. Is set start again. Okay, so let me because the service B is not stable. As you can see here, it's really slow, right? Really slow, and then sometimes it doesn't work. So how can I create a resilient microservice? How can I create a resilient cloud native application? You say, okay, just fix the service B then. Just fix that. Sometimes you don't have authority to fix that. Sometimes all you can do is change yourself. This is same true, right? Like for the family, you just have an argument. It's like, oh, you are doing that wrong. You need to change. It's really, really hard to change others. All you can do is change yourself. So the same thing applies to the software development. So let's change that. So I demonstrate to you how can you easily change yourself, change the operation like your own. So in here, like this is the operation I have. So the on client side. So all I need to do actually, I could use the microprofile like for tolerance. I can do a retry. If something doesn't work, a retry. And also we saw is slow. I can say, okay, please time out. If it does not return within 200 milliseconds, so I save that. As you can see, it's restarted itself. And let's go back here. as you can see, it's no longer like slow, and no longer give you example, wrong information. However, see this number clearly. So the 16, right? Here 17. Here you directly get 19. What happened to 18? Because 18 failed, it automatically did a retry and give you 17. So this is just to tell you is how simple it is to use a macro profile. The other thing is if you want to run in the cloud, the other best practice is you always, for some very critical operation, you should always plug in the fallback. So basically, you can do the fallback. So I do the fallback method. So I can say if this operation failed, I will fall back to my fallback. So basically, I will call this instead. So it's in this way, actually, it's in the cloud, it will automatically will always return you something. Because if this one failed, it will call into my fallback. So the other thing is I want to show you is with the macro profile, basically all the JakartaOne RESTful operations has documentation. So I have the localhost 9080, so open API. So you can see all these, all the JakartaOne, all the the RESTful services has been nicely documented. So it's this is anybody know Swagger? Okay, that's good. If you know Swagger, you know this is identical to Swagger. That's because we adopt Swagger. And then in Open Liberty, you also have a Swagger UI before you ask. So we have a Swagger UI. And then you can just call, this is you can see it do something 200, 400 means what. And then you can try it out here. If I say hello and execute. So you can see a response straight away. So the other thing is also I mentioned I haven't done much, and it gave me a lot of metrics already. So if I do localhost 9080/metrics, so you can see it have a lot of metrics for you, and you can get the request, and also because you use fault tolerance, it even tell you how many times been timed out, how many times retry has been done, and all the operations, JakartaOne operations, RESTful API calls is being traced as well. So it's towards the end. And also because I added a special metrics, metrics more metrics, also give me more metrics. So I show you here is because simply timed, that's from directly macro profile metrics. So here more metrics, you can get more metrics. And also you have to, if you want to count how many times it has been invoked, you have to see at counted as well. So this is the major thing I want to mention. The other thing I mentioned because you eventually want to deploy this application to the cloud. Obviously, you will have a Kubernetes. And then there's something called, in Kubernetes, we know we have a liveness and readiness and a startup check. And then in macro profile, we have 3 endpoints, /health/live/ready and /startup to directly correspond with this Kubernetes, the props. This is a liveness check, and then you can implement this health check. This the method implementation. You could say if you run out of RAM, means this one is not going to live, just destroy this one. And also so for the readiness check, all you need to do annotate with readiness. And here you might say, okay, when is your cloud native application is ready? Maybe it's when the database can be connected. And the third thing is the startup. why we introduce the startup in the Kubernetes? Anybody know? Okay, so in the startup is because I think gradually people all realized that not all cloud-native applications can start in the split millisecond. Some of them will start within a few seconds, right? Maybe 20 seconds even. But Kubernetes, is kind of it constantly trying to do a liveness check. And also do a readiness check, and then you find out, okay, you are still not alive, and maybe you run out of memories need to destroy you, and then Kubernetes run into the deadlock. Basically, before you're ready to start and kill it, and then restart it again. So that's why it came up with a startup check. So basically, do not check liveness readiness before this application said I'm started. So this is about startup. So as you can see here, in the macro profile health, you can see localhost 9080. Here I can see health start live. So you can see all this JSON display, and also you can see ready. And etc. And with I listened to a podcast about best practices one company has been doing in their companies. They said, actually, in my company, I established best practices. All the microservices, they all need to have one single class. They need to provide one endpoint blah blah / health so that I can plug into Kubernetes. With macro profile health, you don't need to do anything. It's just is automatically there. You just implement it. So this is why standard is why it's so important. Has save a lot of effort to negotiate what's the best API, what kind of the class structure should be like. Okay, so prior to this presentation, I already deployed this containerized these two services and also published to my local Docker desktop. So it's running here. As you can see, if I do a kube control get port, so you can see the 2 ports running. 2 ports is because I have 2 replicates here. As you can see, is for Docker file. So I use OpenLiberty, Java 11, OpenJ9. Anybody know OpenJ9? Okay, if you do not know, check it out. It's under Eclipse Foundation. It's really, really cool. And then you run, this is optimize the image. And then you create a deployment YAML. In the deployment YAML, we have 2 apps. One's the app A, so basically you just say the container, so this container image. And this is important. So you might be asking, and in service A, I directly hard-coded service B's URL, right? Do you remember? I said localhost 9081. But once you deploy to Kubernetes, it's no longer localhost. So here, you can configure it. And you say, why you change it to be underscore? Because dot is not a legal character in as an environment variable. So this is the beauty about macro profile config. So it's able to search the environment variable with the normal variables. And if the character is illegal, it automatically converts to be underscore and continue to do the search. So it knows, okay, we'll go in here. The other thing is in my application, I have a conference. So it's basically you remember here. Remember here, I said, hello, Cloud Dev 2020. So that's from the conference name. Is hard-coded in my application. Hard-coded in my application here. I inject the like a conference. And a conference is defined in this microprofile-config.properties is the Cloud Dev 2022. But in the, once it deployed to the cloud, I can override it. I can say JavaLand 2022 and JakartaOne Livestream German. And now, if I go to this directly, go to this endpoint, I know it's on the, which port is on the 380. So you can see it directly is replaced the conference in the local value and with the environment variable directly. So it's automatically fished out. So this demonstrates how can you externalize your configuration using microprofile config. So if you change this one to be a different value, and then you do delete the deployment YAML and apply it, and you will be able to fish out the reflect a new value. So in this we demonstrate you do not need to restart your application again. You do not need to redeploy your application again. So let's go back to the slides again. Okay. So now is probably you by now everybody have heard of serverless, right? Have you all heard of serverless? Are you thinking you are going to do serverless? Anybody? No? Or thinking? You might ask, is the cloud native application obsolete again? So first, what is serverless? Actually, serverless doesn't mean serverless, doesn't mean no server. Often it has server. Most of the time it has server. It only means you don't need to worry about server. It's very small. And the other thing is people often rush to a serverless. They are not even in public cloud. They are on-prem. They say, oh, okay, we need to do serverless. Do you understand the serverless? Serverless is a pay-as-you-go pattern. So basically, you are renting resources. If you are on-prem, you already got resources. Why do you need to do serverless? The third thing is, again, is because the serverless is pay-as-you-go. Obviously, if you are not using, you don't want to pay for it. So that's why you need to scale to 0. And also, you want to start up fast as well. Okay, you might think, okay, is the cloud native application serverless enabled? Actually, this cloud native application can be very fast started. Have you all heard about GraalVM? Okay, a few of them. So GraalVM is one way to enable the application startup fast. And some runtime like Quarkus and Helidon, Micronaut, and trying to use the GraalVM capability. However, there's some downside with GraalVM. It's because it's a hard code. It's kind of almost like the shield when you after the build time. Often, when you build an application, it takes a long time because it's built kind of executable form. And also, you couldn't instrument anymore. If something goes wrong, you don't know what's going wrong. All the APM tooling is no longer to be inserted. And then there's a new technology up here. It's called Linux crawl. So checkpoint restore technology. Checkpoint restore in user space. So basically, OpenG9 utilize that, and also OpenLiberty is trying to utilize the OpenG9, the capability. And now OpenLiberty, this is a microprofile application can start in 70 milliseconds, less than 100 milliseconds. Sometimes it can be even faster. The other thing is that there's a lot of cloud, like a public cloud service, technologies such as, I think yesterday you might have been to a Scale Zero talk from Richard, like IBM Code Engine, Amazon Lambda, Google Function, Azure Function, and etc. all enable you to run the serverless. So simple answer to this, is the cloud-native application going to be obsolete for serverless? No, it's going to stay. And then this is a few takeaway things. Do not use the microservice as a goal. You need to find your problem and fix the problem. If microservice is a way to solve it, do microservices. And the monolith is not evil. When you do microservices, use the best practices. And also learn them, cloud-native APIs to be able to use, to be able to develop your cloud-native applications. And it's also cloud-native application is perfect for serverless. So these are a few takeaways, like a macro profile. You want to find more on Jakarta EE Open Liberty. So this guide has many useful information for you to learn these technologies and then others. So finally, let me finish up with a shameless plug about my book. I wrote last year, published a book on microprofile, practical cloud-native Java development with a microprofile. So it's available on Amazon. Check it out. With that, that's the end of my presentation. Thank you very much for coming and support.
Ich bin unten.
Gibt's Fragen? Do you have any questions to Emily? Ed.
Okay.
Can you say a little bit about what cloud the demo was running on?
This is my personal on-prem Docker desktop.
Gibt's weitere Fragen?
I have tried also on the IBM cloud as well. It runs okay on Azure as well.
Weitere Fragen?
Any questions?
Sieht nicht so aus.
No.
Okay.
Then thank you very much for your keynote, Emily.
Thank you.
Thank you.
We see you in a few minutes.